Hi guys, this is the first video walkthrough for week 10 ratio. Part one is going to be to do with the foundation topics, and then part two I'm gonna have a look at the higher ones. So let's go straight into it. Okay, so these are the notes, and obviously you can download these from Google Classroom. By the end of the lesson, hopefully you'll be able to write ratios in their simplest form. Express ratios in the form 1 to n or n to 1, could be the other way around as well. Use ratio to share quantities, solve ratio and proportion problems, and use fractions and equations in ratios, which will be the higher topics, which I'll show you later on. Let's do the quick introduction to ratio. So ratio obviously is used to describe how two quantities are related, two or more quantities you could have. For example, we might say that orange squash is to be mixed with water in the ratio 1 to 6. This means that for every 1 part squash, you'll need 6 parts water. So if there's 100 milliliters of squash, there would be 600 milliliters of water, and so on. So for however many parts you've got for orange squash, you times it by 6 for the parts for the parts of water. Yep. So what you do to one side, you do to the other. So if you're multiplying one side, let's say you're doubling one side for orange squash, you're gonna have to double the other side for water as well. Yeah, it couldn't work for dividing as well. We'll look into that later on. Obviously, based it totally depends on the question it's asking. So let's have a look at this example. What is the ratio of red counters to yellow? So you've got 1, 2, 3, 4, 5 counters for red and 3 counters for yellow. So you have to write it in the order that they say as well. So they're asking what's the ratio of red counters to yellow. So you have to put the red first. So obviously that's 5 to yellow counters, which is 3. Yep, and you should have 8 counters in total, which we do. Yep, if you add them together. Yep, so you should know what ratio is. Obviously, that's a functional skills topic. So we're going to look into that in more detail. So for GCSE, obviously, we get loads of different types of ratio questions. I'm going to try and show you as many different ratio questions as I can, just so that you get an idea how to solve each one. And, obviously, ratio is a big part of GCSE. So I'm going to try and show you as many as I can in these two videos. So hopefully we're going to do these 8 types of ratio and proportion questions. Probably the first 6 are to do with foundation, and these last 3, I would say they're the more higher ones. So let's have a look at the first 6. Example 1, write ratios in their simplest form. So what is the ratio of red counters to yellow? So we have to do it in the order that they say. So you have to do from red to yellow. So how many red have we got? 1, 2, 3, 4, 6. And we got 2 yellow. Is that a final answer? No, double check. What's it asking for? What is the ratio of red counters to yellow counters? All right, we've written that, but it also says give your answer in its simplest form. So you have to simplify this. Simplifying is very similar to how you simplify fractions as well. So if you had a fraction 2 out of 6, what goes into these? What's a common factor that goes into both 2 and 6? Well, if they're even numbers, definitely 2. So you can divide that numerator by 2, you get 1. And how many 2's go into 6? That's 3. So it's similar sort of method for ratio as well. Instead of going across the page, you go down the page. So of course, 2 goes into 6, 2 goes into 2. 2 into 6 goes 3 times. 2 goes into 2 once, and there's your answer, 3 to 1. You can't simplify anymore. Yeah, just do check, always do check. Does any other number go into both of these at the same time, apart from one, obviously. And if they don't, that's it, you're done. Yep, so let's have a go at these. Obviously, you guys try them yourself first. So if you want to try it yourself, pause the video and I'll go through it. Okay, let's go through these then. So you got 12 to 18. What goes into these? Well, if it's an even number, definitely 2. 2 into 12 is 6. 2 into 18 is 9. Can we simplify any more? What goes into these? Definitely 3. 3 goes into 6 twice. 3 goes into 9 3 times. Can we simplify any more? No, that's it. Yep, so it should be 2 to 3. You'll notice you could do it a different way. Let me just do it on the side. If you think of a bigger common factor, what's the biggest common factor that goes into both of these? You could have chosen 6. Yep, so 6 goes into 12 twice. 6 goes into 18 3 times. You get your answer straight away. So the bigger the common factor, I think the better it is. But obviously, sometimes it's not easy to see. So whichever way you do it, just keep simplifying until you can't simplify anymore. You'll get the same number of marks. Let's try this one. So I reckon definitely 5 goes into these. Yep, 5 goes into that 7 times. 5 goes into that 12 times. Can we simplify it any more? Nope, nothing goes into these apart from 1. So you're done. Let's try this one. I don't want to do the obvious one. Obviously, 2. You can do 2. I want to try a bigger number. Let's try 4. 4 definitely goes into that. 4 goes into that as well. 4 goes into 64 16 times, and 4 goes into 24 6 times. Can we simplify any more? Yeah. 2 goes into that. 2 goes into that. That's 8, and that's a 3. I think that's it. Yeah, we can't simplify anymore, so you're done. Last one, 108 and 48. Oh, I know what we could do. Could probably do 12. 12 goes into that, definitely. 12 definitely goes into that as well. 12 into that is 9 times. You should know your 9 times table, your 12 times table. And 12 goes into that 4 times. Can we simplify any more? Nope, that's it. Yep, and you're done. Yep, just recheck that. 9 12s are 108, isn't it? Yeah. So yeah, just keep simplifying until you can't simplify anymore, and just double check that your answers are right. Yeah. And you're done. Let's move on to the next section. Ratio fraction problems. Okay, so sometimes you will get questions with ratios and fractions in there as well. So let's have a quick example too. In a bag, there are blue sweets and red sweets. The ratio of blue sweets to red sweets is 5 to 3. What fraction of the sweets are blue? Okay. So let's do it in a different color. In fact, I'll keep it the same. So let's write a ratio down first. 5 to 3. So what does a 5 represent? 5 is blue and the 3 is red. Yep, because that's the order they tell you. What fraction of the sweets are blue? Well, this is blue right here, 5. And fraction. So you need this. You need the number of blue sweets out of the total. Well, the total is both of them together. So you got 5 plus 3, which is 8 sweets in total. So it's 5 out of 8. That's got to be your answer. Yeah. Let's move on. So if you guys want to try these practice questions yourself, give them a go. Pause the video. Yeah. Let's go through them now, though. So in a bag, there are blue sweets and red sweets. Ratio of blue sweets to red sweets is 2 to 7. What fraction of the sweets are red? Well, there's 7 red out of 9. So you got 7 out of 9. That's the answer for that one. In a bag, there are blue sweets, red sweets, and green sweets. So you got blue, red, and green in the ratio 5 to 3 to 2. What fraction of the sweets are green? Well, you got 2 green out of total, which is 10. So it's 2 out of 10. Yep, or you can simplify it to 1/5 if you wish. Both answers are perfectly fine. It doesn't say simplify, but so you don't have to. So both these answers are perfectly fine. Whether you put 2/10 or 1/5 makes no difference. 2C. In a bag, there are only red sweets and yellow sweets. 2/3 of the sweets are red. Write down the ratio of red sweets to yellow sweets. Okay, so 2/3 are red. So if 2/3 are red, if there are only red sweets and yellow sweets. So if 2/3 are red, what are the rest? Well, the rest has got to be, if you take it away from one whole, it's got to be 1/3 yellow. Yep. Write down the ratio of red sweets to, okay, so the ratio from red sweets to yellow sweets. So that's got to be 2/3. That's 1/3. We don't like ratios. We don't like ratios. We don't like fractions in the ratios. We need them as whole numbers. So if you times that by 3 to both sides, you'll get rid of the fraction. So that's going to be 2. And that's going to be 1. So it's 2 to 1. Yeah, there's your answer. 2 to 1. Question 2D. In a company, the ratio of men to women is 2 to 3. 30% of the women are under the age of 30. What fraction of all the people in the company are women under the age of 30? Okay, so let's write a ratio down first. 2 to 3. So what does the 2 represent? That's the men, and that's women. Okay, so 30% of the women, so 30% of these are under the age of 30. What fraction of all the people in the company are women under the age of 30? So we want to work out 30% of this. Well, what is this? That's 3 out of, well, we've got 2 plus 3, which is 5 parts. Yeah, so it's 3 out of 5. So you want to work out 30% of this. Let's do it as, because obviously we want our answer as a fraction. We don't want percentages. So let's work out 30% of 3/5. That's what we need. Let's simplify it. What we can do is look diagonally. So 5 goes into that once, 5 goes into that 6 times. Can we simplify any more? I think that's it. 6 times 3 gives you 18 over 100. Oh, we can simplify more, definitely. You don't have to, but yeah, you can leave it like that. But let's simplify it. Okay, let's divide this by 2. So you get 9 over 50. Yeah, you could get your answers 18 over 100 or 9 over 50, whichever. Yeah, both answers are perfectly fine. Let's move on to the next section. Express ratios in the form 1 to n. So in order to write a ratio in the form 1 to n, you must take the left-hand side of the ratio equal to 1. Okay. Alternatively, in order to write a ratio in the form n to 1, you must take the right-hand side of the ratio equal to 1. Yep, so you could be 1 to n or n to 1, totally depends on the question. So let's have a look at this example. Write the ratio 4 to 20 in the form 1 to n. Well, n is just the unknown. Yeah, that's the way I think of it. So n is our unknown. It could be anything. So we want to write 4 to 20 in the form 1 to something. Yeah, so we don't know what that something is. We need to fill in the blanks. So if you write it like this, I think it's a lot easier. You know, to write your ratio first. 4 to 20, we want 1 to something. So how do you get from 4 to 1? Well, you'd have to divide this side by 4. Yeah, and whatever you do to one side, you have to do to the other. You have to has to be the same. So you have to divide 20 by 4. So that's 5. And there's your answer. You've got it 1 to something. In this case, it's 1 to 5. Yeah. Let's have a look at the next ones. So yeah, if you want to try these practice question 3, A, B, C, and D yourself, pause the video and unpause it when you're ready. So let's go through part A, 5 to 45 in the form 1 to something. So to get from 5 to 1, I'm going to have to divide that by 5. So I'm going to have to divide this side by 5 as well. How many 5s go to 45? 9. Yep. Oh, it's a bit of a weird one. 0.5 to 2.5 in the form 1 to something. Well, to get from that to that, to get from a half to 1, we're going to have to double it. So I'm going to have to double this side. What's 2.5 times by 2? That's going to be 5. Yep. This time we've got 125 to 5 in the form something to 1. Again, to get from 5 to 1, I'm going to have to divide by 5. So you're going to have to divide this side by 5 as well, which is 25. So your answer is 25 to 1 for that one. And finally, 6 to 0.25 in the form something to 1. So to get from this to this, that's a quarter, isn't it? Quarter to 1, well, I'm going to have to times it by 4. So you're going to have to times this side by 4 as well, which is 24. Yep. These could be on non-calculated paper as well, by the way. So you need to know your multiplication tables, your divisions, obviously, up to your 12 times table. They will definitely help. Okay, section 4, using ratio and proportion in solving problems. Example 4, 15 rulers cost £3. How much do 40 rulers cost? So again, this is definitely functional skills. So if you've got 15 rulers for every £3, we want what 40 rulers is. Well, to get from 15 to 40 in one step is quite a big step to go from. So maybe do a step in between. I always work out what one ruler represents and then go to 40. So to get from 15 to 1, you have to divide it by 15. So we'll have to divide this side by 15 as well. I think that's going to be, yeah, 0.2. So obviously in pounds, that's going to be 20 pence. So if one ruler is 20 pence, 40 rulers is going to be 40 times that. So you're going to have to times this side by 40, which is 8. And that's going to be pounds. Yep, and there's your answer. So it's a really good way of doing it. Always work out what one thing represents and then go from there. Very similar to reverse percentages. You know how you work out what what 1% is, and then go from there. Very, very similar method. And it works really well for these type of questions. It doesn't say use this method. You know, I think it's a good way of doing it though. So let's have a look at these other questions. Obviously, try them yourself, pause the video, and then unpause it when you're ready. So practice question 4A. 2 tubs of ice cream cost £5.90. How much would 5 of these cost? Okay, so you got 2 tubs. Represents £5.90. Okay, we want 5. Let's work out 1 first. 1 tub to get from 2 to 1. We'll have to halve it. So let's halve this side. Yep, £5.90 divided by 2. £2.95. That's for 1 tub. So for 5 tubs, you're going to have to times it by 5. Let's times this side by 5, which is £14.75. No, obviously, if it's not on the calculator paper, you're going to have to work it out on the side, which, you know, you guys can definitely do. Yeah, I'm just using my calculator just to save a bit of time. 4B. 2.5 kilograms of carrots cost £1.70. Work out the cost of 3.25 kilograms. Okay, well, 2.5 kg represents £1.70. We want 3.25 kilograms. Let's work out what 1 is. To go from 2.5 to 1, I'm going to have to divide by 2.5. So we're going to have to divide this by 2.5. So £1.70 divided by 2.5. That's 0.68. Okay. So to get from 1 kilogram to 3.25 kilograms, you're going to have to times it by 3.25. Yep, let's multiply this side by 3.25. We get £2.21. Yep. Next one. 90 hazelnuts have a mass of 125 grams. Hazelnuts have 630 calories per 100 grams. Work out the number of calories per hazelnut. Oh, it's a bit of a weird one. Okay, well, 90 hazelnuts represents 125 grams. We want it per hazelnut, so let's do it for 1 hazelnut. How do you get from 90 to 1? I'm gonna have to divide that by 90. Yep, let's divide that by 90 as well. So 125 divided by 90. Oh, we get a recurring. Let's do it as a fraction. That's more accurate. So don't do it as a. Don't write it down as a decimal. You can, but I wouldn't recommend it. Let's do it as a fraction. 25 over 18. It simplified it for you. That's in grams. It's a lot more accurate. Okay, so for 1 hazelnut, that's how many grams it is. Work out how many calories. So we're told that 630 calories represents 100 grams. Well, for 1 hazelnut, we've got that many grams. We want, I tell you what, let's do a stage in between. Let's work out what it is for 1 gram first. Well, we'll have to go from 100 to 1, which is, you have to divide it by 100 on this side. Let's divide that side by 100. So it's 630 divided by 100. 6.3 calories per gram. We want it for 25 over 18 grams. So you're going to have to times it by that much. So you're going to have to times this by 25/18. Let's do it as a fraction. Times 25/18. We get 8.75. Yeah, that should be your answer. So it should be 8.75 calories. If you don't get that answer, you've gone wrong somewhere. You know, you've probably rounded this bit here, which is technically it's a recurring decimal. So yeah, if you start rounding things halfway between your answer, then your final answer is going to be slightly off, and it obviously will be wrong. So yeah, try not to round things and just use exact values. Practice question 4D. Carrots cost £1 for 1.2 kilogram bag at Tesco. Same type of carrots cost 77 pence for a 700 gram bag at Asda. Where are the carrots better value? So when you've got a question like this, you've got two things going on here. You've got Tesco and Asda. I personally prefer Aldi, but it's not in the question, so we'll ignore that. Carrots cost £1 for 1.2 kilograms of carrots. Okay, and Asda, it's 77 pence. Let's write it like this: 77 for 700 grams. Okay, we can't really compare it at the moment because obviously that's £1 per 1.2 kilograms at Tesco, and that's 77 pence for 700 grams. That's in kilograms, that's in grams, so you got different units here. Let's change that. In fact, let me change that. Let me change that to kilograms. So obviously we've got 1 kilogram equal to 1,000 grams. Yeah, that's something that you definitely need to know. That's essential. So what would 700 grams be? That would be 0.7 kilograms. Yep, so now we can, that's a little bit better. That's a little bit better now. So now we've got kilograms, there as well. How shall we compare this? Well, that's £1. That's 77 pence. Let's change that to 77 pence as well. Well, to get from that to that, you'd have to no, in fact, let's do it the other way around. Let's go. Let's do going from 0.77 pounds or 77 pence to £1. Yeah, and then you can compare. But to get from that to that, how many 77 pences go into 1? So you'd have to do 1 divided by 0.77. Okay, obviously it's a decimal. In fact, I'm gonna leave it as a fraction. So you'd have to multiply this because it's getting bigger. Obviously, you're going from a smaller number to a bigger number. It's times by 100. This is what's coming up on my calculator as a fraction. Yeah, what I did was I did £1 divided by 0.77. How many of these go into that? Yeah, and it's that much times bigger. So you're gonna have to do the same to this side as well, times by 100 over 77. Let's do that. So times by 0.7. That gives us as a decimal 0.909 kilograms. All right. So now you're comparing this with this. So which one's better value for? Well, for £1, you'll get more. You'll get more carrots per kilogram. Sorry, more carrots in terms of weight for £1 at Tesco. So your answer is, which one's better value? So obviously the Tesco is better value. You'll get more carrots per pound. So definitely Tesco is your answer. It's probably cheaper at Aldi though, definitely. Let's go to the next question. Next section, using ratio to share quantities. So this is when you've got two or more things that you're comparing in the ratio. Let's have a look at this. So you got two different methods. Depends on if the question mentions the total or just a part of the ratio. Yeah, so they're going to be two different methods for these type of questions. So you do have to look for the clues in the question. Okay, so if in the question it's giving you the whole amount, then we do the method where you add the ratios and then work out what one part is and do it that way. If in the question you haven't got the whole amount, if they've just told you what one thing it is, then you're gonna have to do it a different way. So it's not always the case where you add the ratios and divide by how many you've got and you get what one part is. So everyone seems to assume that that's the only method that you use for working out ratios. It's not the case at all. So it totally depends on what information they've given you in the question. Okay, so let's have a look at these two examples. Example 5a, for mortar is made from sand and cement in the ratio 7:2. If 21 buckets of sand are used, how much cement is needed? Okay, let's write the ratio down first. So we've got 7:2. Yep, so the 7 represents the sand and the 2 is the cement. So that's the order that they've told you. If 21 buckets of sand are used, so the 21 represents just the sand. Yeah, so it's not both of them together. It's not just the cement, it's just the sand. So it has to go underneath this column right here. So it has to go underneath in the sand sections. It has to go here on this side. Yep. How much cement is needed? So to work out what our unknown value is here on this side, how do you get from 7 to 21? How many 7s go into 21? Well, it's 3. So it's 3 times bigger on that side. So you'll have to multiply this side by 3 as well, which gives you 6. Don't forget to write the correct units. Can't just leave it as 6. Don't forget they used buckets in this case. So your answer is going to be 6 buckets as well. Yep. All right, next example. Let me just scroll up a little bit, so I'll just leave it there. Jess, Mo, and Greg share £9,100 in the ratio 2 to 4 to 7. How much does Mo get? Okay, let's write our ratio down. So we've got 2 to 4 to 7. So 2 is Jess, 4 represents Mo, 7 is Greg. Okay, and this £9,100, that's shared between the 3 of them. So that's all 3 of them all together. So that's the whole amount shared between all 3. So how many parts will that be altogether? So Jess has got 2 parts, Mo's got 4 parts, Greg's got 7 parts. How many parts is that altogether? That's going to be 6 plus 7. That's 13 parts. Yeah, altogether in total. Yeah, so you got 13 parts in total. Those 13 parts must equal the whole amount, which is £9,100. So if 13 parts equals that, what's one part going to be? Well, if 13 parts is £9,100, you're going to have to divide that by, oops, oh, where's it gone? Oh, blimey. Silly thing. There we are. I don't know why it did that. You're gonna have to divide it by 13. Let's try that in the calculator. 9,100 divided by 13. 700 exactly. All right, so that's going to be 700 pounds. Don't forget the units. Yeah, this is the bit that's the most important, working out what one part represents. Yeah, because once you've worked out what one part is, you can work out 2 parts for Jess, 4 parts for Mo, 7 parts for Greg, any number of parts it asks for. Yeah. In this case, they're asking how much does Mo get? Well, Mo gets 4 parts. So for Mo, it's got 4 parts, which is 4 times what one part is, 700, which is going to be £2,800. Yep, and there's your answer. If obviously if it asks for Jess, you're gonna have to times it by 2, or if it asks for Greg, you'd have to times it by 7. So yeah, once you've got what one part is, it's dead easy after that. And you can work out any number of parts. So there's 2 examples, 2 different methods. Totally depends on whether they've given you the whole amount in the question. In this case, they did. You know, they told us that the £9,100, that was the whole amount that's being shared by all of them. Whereas in the previous question, they said the 21 buckets was just for the sand. So you put it underneath the sand section, and then you do it, you know, see how many times bigger that side is. You have to do the same to the other side. So 2 totally different methods. Totally depends what information they've given you in the question. So do look out for little clues like that. Have a go of the rest of the questions yourself. Pause the video, and I'll go through the answers. I'll do that right now, in fact. So hopefully you've had a go. So practice question A, 5A. Lewis, is it Lewis? And Jack divide the profits of their business in the ratio 3 to 4. If Jack gets £600 as his share of the profit, how much profit did the business make altogether? Okay, all right, so let's write the ratio down. I always write the ratio down first. Let's do that. Yep. What does the 3 represent? So 3 is for Lewis, 4 is for Jack. Okay, Jack gets £600. There you go. Right, so Jack gets £600. So the £600 goes underneath this section, Jack. Yeah. So how do you get from that to that? How many 4s go into that? I don't need to work that out. That's 150. Yeah. Yeah, do the same to that side. And that's going to be 450 for Lewis. Is that our final answer? Let's just double check. No, they're saying how much profit did the business make altogether? So the total, well, total is going to be both of them together. So the total 450 plus 600, which is £1,050. That's your final answer. Yep. Next one. Amy, Beth, and Colin share 36 sweets in the ratio 2 to 3 to 4. Work out the number of sweets that each of them receives. Okay, so 2 to 3 to 4. That's Amy. That's Beth. That's Colin. 36, what does the 36 represent? That's what they all share, so all 3 of them all together. So we're going to have to do that other method where you add the ratios. That's going to be 9 parts altogether. So that's 9 parts, which equals the total amount, which is 36 sweets. So if 9 parts equals 36, 1 part will be 36 divided by 9, which is 4 sweets. There's your crucial bit. Finding out what 1 part represents. Definitely highlight that bit. Yep. It's dead easy after this now. So once you worked out what one part is, well, Amy had 2 parts, so it's 2 times 4, 8. There's your first answer. Beth had 3 parts, 3 times 4, which gives you 12. And Colin had 4 parts, 4 times 4, which is 16. Yeah, and if you add these up, you should get 36. You know, to check that you've done it right. If you add 8 plus 12 plus 16, you should get 36, and we do. It's a good way of checking whether you've done it right. Good. Next one. Practice question 5C. Ratio of girls to boys in a school is 2 to 3. What fraction of these students are boys for part A? Okay. Well, ratio of 2 to 3. 2 represents the girls. 3 is boys. What fraction are boys? So it's going to be 3 out of 5. Yeah, because the total is 5. So if the total is 5, it's 3 out of 5 for boys. In year 8, the ratio of girls to boys is 1 to 3. Let's write that down. So 1 to 3. Girls to boys. Okay. There are 300 students in year 8. Okay, so that's all of them. Work out the number of girls in year 8. So 300, that represents the total amount, boys and girls. So we're going to have to add the ratio. That's 4 parts. Those 4 parts equals 300 students. 1 part will be 300 divided by 4, which is, being a bit lazy here, 75 students. Yep, again, there's a crucial bit. Oh, let's highlight like this. Yep. 1 part is that. So work out number of girls. How many girls? What was the number of parts for girls? So for girls, it's 1 part, which is, oh, there's your answer straight away, 75 girls. Yep. Dead easy. I know it's a bit tedious to, you know, write down, add the ratio, 4 parts equals this, and 1 part equals that. But I think it's a good idea to do it. You know, I know a lot of people try to cut corners, but I wouldn't recommend cutting corners. You know, I think it makes sense, not only to yourself, but for the person marking it as well. You know, you need to make sure that the working out is clear and precise, you know, for the person marking it. You know, just make sure that you get full marks. For me, you know, it just makes more sense, to be honest. So if you stick to these methods, you know, you'll get it right every single time. You'll get full marks. Let's go on to practice question 5D. Anne and Bob shared £240 in the ratio 3 to 5. Anne gives half of her share to Colin. Bob gives a tenth to his share to Colin. Where's Colin come from? What fraction of the £240 did Colin receive? Right, okay. Let's write down what we've got so far. Let's do the ratio. I always write the ratio down first. 3 to 5. So 3 is Anne. 5 is Bob. They shared £240. Okay, right. Colin's not even in the ratio. So we're going to have to work out how much they share between Anne and Bob, how much they share the £240. So it's one of those where you add the ratios. Yeah, because the £240 is the total between Anne and Bob. That's 8 parts. 8 parts equals £240. So 1 part, 240 divided by 8, which is £30. Yep, there's a crucial bit. So let me just rewrite the ratio here, 3 to 5. So times that by 30. times that by 30. So Anne gets £90. Bob gets £150. Yep. So that's the first bit, working out what Anne's got and what Bob's got. So Anne gets £90, or Anne has got £90, and Bob's got £150. Anne gives half of her share to Colin. Well, so Anne gives half of that to Colin. So Colin gets £45 from Anne. And Bob gave a tenth of his share. So a tenth, we need a tenth of 150, which is £15. So Colin gets 45 plus 15, which is £60. Oh, we need it as a fraction. What fraction of the 240? So it's 60 out of 240. That was the total, wasn't it? Yep. Out of, yeah, fraction out of 240. You can leave it like that, or you can simplify it. What's that going to be? 1/4, isn't it? Yep. So again, either this or this. It doesn't say simplify. You don't have to. So you can just you could have left it as 60 over 240, to be honest. Or if you did simplify, it would be 1/4. Yeah, next one. Practice question 5E. Last year, Kerry's take-home pay was £15,000. She spent 40% of her take-home pay on rent. She used the rest of her take-home pay for living expenses, clothes, and entertainment in the ratio of 3 to 1 to 2. How much did Kerry spend on entertainment last year? All right, so okay, so the rest. Let's work out the rest first. So 40% of that was on rent. So 40% of 15,000 was on rent. What would be the rest? Well, the rest, that's for rent. The rest, just fix that 1 sec. Rent. Yep. The rest is equal to 60% of 15,000. Let's work that out first. 60% of, so that's 60% of 15,000, which is 9,000. Okay. And that's being shared in the ratio 3 to 1 to 2. So 3 is what is 3? That's living expenses. The 1 represents clothes, and the 2 is entertainment. Yep. So this represents the whole amount of the ratio. Yeah. So we need total number of parts. A plus 1 plus 2, which is 6 parts. Those 6 parts equals the £9,000. So 1 part will be 9,000 divided by 6, which is, let me write that down. 9,000 divided by 6, which is £1,500. Okay, that's for 1 part. Let me highlight that. It's a crucial bit. What's asking for? How much did she spend on entertainment? Well, entertainment, where's that? 2 parts for that. There you go. So for entertainment, 2 parts times by 1 part gives you 3,000. It's a lot of money to spend on entertainment. That's your answer. There you go. Yep, just do it step by step. Me personally, I would always write the ratio down. I didn't have to write it down for this one first. I had to work out what percentage you needed first, and then write your ratio down, and then go from there. Yeah, and it's either going to be this method where you add the ratios, or it's going to be that other method where you multiply one side, you got to multiply the other. Yeah, so totally depends on what information you're told. Let's move on. Section 6, using ratios and proportion in scale. Yes, this is quite interesting. This kind of thing comes up in both Edexcel and AQA quite often. Let's have a look at this example. This is taken from an Edexcel paper, by the way. The diagram shows a tree and a man. The man is of average height. The tree and the man are drawn to the same scale. Write down an estimate for the real height in meters of the man. This threw a lot of people. You know, when they did this in a real exam, everyone was saying, what on earth was that question about that bloody tree, about that bloody man? They didn't have a clue what was going on. What is it asking for? Write down an estimate for the real height in meters of the man. Basically what they're asking, what is the average height of a man? There's no working out for this. It's supposed to be common sense. Supposed to be. So what is the average height in meters of an average person or average man? Well, it's not going to be 2 meters. 2 meters is too tall. Let's say just less than 2 meters. Let's call it 1.7 meters. Yeah. And in the exam, if you said 1.6 meters or if you said 1.8 meters, that's fine as well, to be honest. Or even 1.5 meters. They'll give you a bit of leeway in the exam. You know, obviously, everyone's going to have a slightly different answer. If you put 2 meters, that's too much. If you put 1 meter, that's too small. So somewhere between roughly 1.5 to 1.8 meters. I think 1.8 is a little bit too much, to be honest. I think 1.7 is about right. Yeah, but it's one of those. You're not supposed to work it out. They're just asking what is the average height of a man. Yeah, and we're going to use this, obviously, this is for part A. We're going to use it for part B. So part B says, find an estimate for the real height in meters of the tree. Right, so what we're told that the tree and the man are drawn to the same scale. What do we know about scale? Well, scale drawings are to do with measurements, and you need to measure things on the paper, and that's going to relate to what it looks, what it's going to be in real life. So you're going to have two things. Your scale is your ratio. So obviously you're going to need a ruler for this. Let me get a ruler. One sec. Where's my ruler gone? I'll grab that. I've got a better ruler than that. That'll do. One sec. There we go. That's a better one. Okay. Put these away. So on your paper, yours might be slightly different because obviously it's the way it's been printed. It's supposed to be, I think it's about 0.8 centimeters for the man. Yeah, so let's say, for argument's sake, you know, because everyone's is printed differently. It depends how it's printed. I've got about 0.8 centimeters for the height of the man. Yeah, obviously you're gonna have to use a ruler. You're gonna have to print these out. I'm using the screen, which is a bit unusual. Let me try it on that side for that. What's it gonna be for that? I got about I'm getting about 4.2 centimeters for the tree. So obviously yours is going to be slightly different as well. So let's say for the tree, I've got 4.2 centimeters. And obviously you know, don't start saying, oh, mine's 4.3 or mine's completely different. It's not going to be massively different, but yeah, on mine, it totally depends on how it's printed. Yeah, again, let's, for argument's sake, let's say you've measured these two things and you got 0.8 for that, for the man, and 4.2 for the tree. Okay, so obviously our scale is so 0.2, because if it's not 0.2, if it's drawn to the same scale, that means for every for 0.2 centimeters, that's for the man. Yeah, you got 4.2 for the tree. Okay, so what if you, obviously because it's drawn to scale, what if you do to one side, you've got to do to the other. So if you double the height of the man, you double the height of the tree, and so on. So that's going to be, this is obviously in centimeters. Your trees, you know, you don't measure trees in centimeters though. So we said that the man's real height was 1.7 meters. Let's put that on this side. So 1.7 meters. These were centimeters, weren't they? Not centimeters as well. Okay. So let's change that. In fact, let's change that to centimeters. Let's change that to centimeters. So instead of writing 1.7 meters, let's call it 170 centimeters. That's better. Yes, now everything's in centimeters. How do you get from that to that? How many 0.8s go into 170? So 170 divided by 0.8. I get 212.5. Yep, let's do the same to this side. We have to times it by 212.5. 4.2 times that. What do we get? 892.5 centimeters. We want it in meters. Okay, so we're gonna have to change it back to meters. So obviously there's 100 centimeters in equal to 1 meter. So how many hundreds go into that? Divide your answer by 100. This will definitely be on the calculate paper, by the way. 8.925. And again, in the exam, they'll give you a bit of leeway. If you got between probably about 8.8 or 9.2, you know, you'll get roughly about 9 meters as your answer. Yeah. So don't be put off by questions like these. They're a bit weird, but yeah, that's all it is. Obviously, if it's mentioning anything to do with scale, you're going to need one of these, obviously. Yeah. Let's move on. So in fact, no, let's not move on. Let's go on to these questions. Practice question 6A and so on. Try these yourself. Obviously, you're going to have to print these out. You're going to need your ruler. So obviously, it's to do with scales and stuff like that. Try it yourself. Pause the video, and I'll go through it as well. So, practice question 6A. The picture shows a bus next to a building. The bus has a length of 12 meters. The bus and the building are drawn to the same scale. There's your clue right there. Work out an estimate for the height in meters of the building. Right, so in this case, just be careful. It's asking for the height of the building. So we need, obviously, the length from there to there. In real life, obviously. Yeah. But we're going to have to use this as a scale. So if you measure let's measure the bus. What do I get here? I get about 2 centimeters for the bus on mine. So when I measure it, I get this to be 2 centimeters. So our scale, they've actually told us what it is in real life. So our scale is 2 centimeters on the map represents 12 meters in real life. That's our scale. Let's measure the building. I get 5 point. Is it exactly 5? Or is it? It's a bit tricky to do on the screen. I get exactly 5 on mine. No, actually, no, it's not. I get 5 point. Just over 5. I get 5.2 on mine. So let's call it 5.2 centimeters. Obviously, you'll have something different. The way it's the way it's printed. Totally depends what yours is. In the exam, obviously, everyone's just going to be the same. It depends on how big it's printed. It depends on the scale, how it's been printed, and everything like that. Let's call it 5.2 centimeters on mine. That's what it is. That's how I've measured it. Yours might be slightly different. So obviously that's 5.2 centimeters on the map. So that goes underneath here. How do I get from that to that? How many 2's go into that? So 5.2 divided by 2. 2.6. So I'm timesing it by 2.6. So I'll have to times this side by 2.6. I get 31.2 meters. Yeah, and it's an estimate, obviously, because it's not going to be accurate, is it? So if you got roughly 31 point something, or if you got roughly 30 something, 31, something like that, that's your answer. That's absolutely fine. Yeah, again, they'll give you a bit of leeway in the exam. Let's move on. Practice question 6b. ABC is a straight line. The length of AB is 5 times the length of BC. AC equals 90 centimeters. Work out the length of AB. Oh, this is a good one. There's a couple of ways you can do this. You could use algebra. You can use ratios. Whichever, you'll get the same answer. In fact, I'll do it both ways. Let's do ratio first, because that's obviously the topic that we're doing. Length of AB, that's from there to there, that's 5 times bigger than BC. So if let's say from B to C is 1, that's going to be 5. Yeah, so it's the ratio of 5 to 1. That's 5 times bigger than that. We're told that AC is 90. So let's do it this way. The 90 centimeters, that's the total amount. Yeah, that's the whole thing from A to C. So we want the total number of parts. So 5 plus 1, which is 6 parts. Those 6 parts equals the 90 centimeters. So 1 part will be 90 divided by 6, which is 15. Yep, 15 centimeters. There's your crucial bit, finding out what 1 part represents. Work out what AB is. Well, AB was 5 parts, so AB is going to be 5 times 15, which is it 75? Let me just double check. Yeah, 75 centimeters. There's your answer. Yeah, or you could have used algebra. In fact, let me do algebra in a different color. Let's call that X. Let's call the smallest amount X. Let's call that bigger one. If it's 5 times bigger, 5 times, so it'll be 5 times X, which is 5X. It's the same sort of thing. So 5X plus 1X gives you the total amount, which is 90. Simplify this. 5X plus X gives you 6X. And divide both sides by 6. So X equals 90 divided by 6, 15. Don't know why I did that twice. 15 centimeters, that's what X is. That's not the final answer. What's it asking for? Work out the length of AB. What AB was, we said AB was 5X. So AB is 5 times 15. It's pretty much the same working out, isn't it? 75 centimeters. So whether you use algebra or ratio makes no difference. You're going to see you're still going to get the same answer. Still get the same number of marks. Makes no difference whatsoever how you do this. Yep, as long as you get the same answer. Practice question 6C. PQ are lines of length 12 centimeters. PR to RQ is 1 to 3. Mark point R on the line with a cross. Oh, that's a good one. So PQ are lines of length 12 centimeters. So between P and Q, they're saying that's 12 centimeters. That's the total amount. PR to RQ is 1 to 3. So okay. So how many sections have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have got 12 sections. All right. How should we do this? P to R. So let's write down a ratio 1 to 3. That's P to R. That's R to Q. Okay. So we want to mark R. So R is going to be somewhere along here, definitely, obviously. So we want, technically, we want to work out what PR is. Let's see, what's the best way of showing you? So obviously, if 12 is the total amount, 12 is from P to Q, we can add our ratio. Oh, why am I doing this in this pen? Sorry. Let me do it in this. Let me rewrite this. 1 to 3, P to R, R to Q. Okay. So the total is 4 parts. Those 4 parts equals the 12 centimeters, or the 12 sections. So one part is going to be 3. In fact, let me show you why it's 3. 12 divided by 4, which is 3 centimeters. Yep. Okay, there's a crucial bit, finding out what one part represents. So P to R is 3. And because P to R is equal to 1 part times by 3, which is 3 centimeters. So it's 3 centimeters along. Yeah, which is going to be 1, 2, 3 right here. So mark on the point R. R is going to be here on the line. Yep. Or you could have done R to Q. R to Q is 3. 3 times 3, which is 9. Could go 9 squares backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it makes no difference. You'll get the same answer. P to R is probably easier. It's three spaces along. There's your answer. Just want to mark it on the line where it is. Dead easy. So that's all the foundation type questions done. So in the next part, I'm going to do the higher type questions. So we're going to do 2 or more ratios in the same question. Which other ones are there? We're going to do difference of 2 ratios. That's a bit of a tricky one. And the most difficult ones are when you've got equations in ratios. So obviously it's got things to do with algebra. Not as simple as it sounds, but hopefully when I go through the video, it'll make more sense. And you know, if you stick to those methods, I think you can't go wrong, to be honest. Bit weird, but once you get your head around it, it's not too bad. So I shall see you in the next video.